Hello everyone, I'm Murtaza Aşıla, first year Electrical and Electronics Engineering student at Bilkent University. This video is my presentation of my Physics 102 laboratory project about measuring and examining the internal resistance of a battery.
In electronic circuits, electromotive force is usually provided from batteries. An ideal battery is a battery that produces a constant potential difference to the circuit that is independent from the current passing through the battery. But in real-life batteries, there is an internal resistance which causes a decrease in the potential difference provided to the circuit when the current that is passing through the battery increases. And the relation is given by the equation that you see, where V is the voltage provided to the circuit, epsilon is the ideal electromotive force of the battery when it is not connected to the circuit, I is the current flowing through the battery, and R is the internal resistance of the battery. Therefore, we can conclude that it is expected a linear relationship between the current on the battery and the potential difference in the circuit. Furthermore, we can state that the slope of the graph of V versus I will give the negative of the internal resistance of the battery, and the y-intercept of the graph will give the ideal electromotive force of the battery. The equipments that I used in the experiment were a 9-volt battery, variable resistors, a multimeter, wires, and a breadboard. Firstly, I measured the potential difference on the battery by using a multimeter. Then I designed the circuit as can be seen in the image, with the highest resistance resistor. I firstly measured the potential difference on the circuit with this design and recorded the results. Then I changed the circuit a little bit to measure the current, which means I connected my multimeter in series to the circuit and measured the current and recorded these results too. Then I repeated the steps for 7 different resistors, and some of the results for voltages can be seen in this image. The current results respectively to the voltages in the previous image were like this. The recorded data of the results for voltages and currents for the corresponding resistor connected to the circuit can be seen in this table. Lastly, here is the graph of V versus I, which is drawn by using the data in the table and the equation obtained by drawing the best fit line. By using the equation, we can obtain the slope and the y-intercept of the best line. The slope is minus 0.00873, but since our current values were in milliampere, we need to multiply this by 1000 to obtain the resistance in ohm. Therefore, the internal resistance of the battery is approximately 8.73 ohms. And the y-intercept of the best line is approximately 9.44, which is the experimental electromotive force of the battery. Overall, we can state that a linear relationship between the voltage and current were obtained, where the voltage decreases linearly when the current is increased, which meets our expectations in the theory. The errors in the experiments were maybe caused from the multimeter could not give exact results in such a small current, the resistors were heated up when connected to the battery because of the current, and the heat changed their resistances, especially for low resistance resistors. This can be also seen in the graph too. The resistances of the wires, which were considered as zero in the theory. That was my conclusion from this experiment. Thank you for watching.